So first of all, welcome to Physics of Motion. We are going to talk about acceleration today. So who can tell me, and let's raise our hands like this if you want to answer the question. Who can tell me what acceleration is? Charlie.
Acceleration is, let's say you're not actually driving your car, but you're in it and you're going down a hill. You just normally start off slow, and then as the car it's heavy, so it's pushing it down, and as it starts going faster and faster and faster and getting momentum, and that is acceleration.
Acceleration, yes, is the change of speed over time. So it's changing your speed. You start going faster. Acceleration is actually going slower. Also, they call that deceleration, but it's a factor of acceleration. And the other thing that's part of acceleration that we often don't consider is the idea of changing direction. So acceleration has to do with direction and change in speed. So I'm going to share my screen now with a little video that explains that for us. Just a second while my screen pops out. I don't know why it's taking time to do. There we go.
I'm Virgil Ricks, and this is 2-Minute Classroom. Today we're talking about motion. Specifically, we're talking about speed, velocity, and acceleration. And let's get to that. First of all, speed and velocity are different, and acceleration is much more than just speeding up. Speed is the rate at which something changes its position. It's represented as distance over time. Miles per hour, kilometers per hour, meters per second. These are all examples of the units for speed. So if you're driving in your car at 72 miles per hour, then that's your speed. In fact, it's your instantaneous speed, or your speed in that exact moment. If you get to the end of your trip and realize that it took you 2 hours to drive 120 miles, then your overall speed was 60 miles per hour. And this is also known as your average speed. Velocity is a lot like speed, except for one important difference. It's a vector, which means it has a direction attached to it. So while your speed may have been 72 miles per hour, your velocity was 72 miles per hour east, or 72 miles per hour towards the beach. There just has to be some direction attached to the speed to make it a velocity. With that knowledge in hand, you're now ready to understand acceleration, which is simply the rate at which velocity changes. It's represented as distance per time, or distance per time squared. For example, meters per second squared are common units for acceleration. Anytime you change your velocity, you are accelerating. That can be speeding up or slowing down, which is also known as negative acceleration. But direction is also a component of velocity. So when you change your direction, even if your speed doesn't change, you are accelerating. Does that blow your mind? All right, let's recap. Speed is the rate at which something moves, distance over time. Velocity is speed with a direction, so distance over time with a specific direction. And acceleration, the king of them all, is distance over time squared, or the rate at which velocity changes. Whether you're speeding up, slowing down, or changing directions, you're changing your velocity and thus accelerating. Science is so cool. I hope you enjoyed this video. Feel free to throw any comments below, whether it be questions, criticisms, or just idle chit-chat. I'd love to hear it. Don't forget to watch and share my other...
Okay.
I couldn't see any of that.
That was so funny.
Okay, just a second. Okay. So who couldn't hear any of that?
I couldn't hear or see it.
You couldn't hear or see it. Can you hear and see me?
Yes.
Okay, cool.
I can.
And so did other people hear or see that video?
I did.
I did.
Cool. So Austin, let's just go over what the content of that video was. So Austin, what did it say speed is? How did they define speed?
How fast you're going?
Yeah, how fast you're going, and it's the relationship of how far of a distance in how much time. So speed is always measured in something like meters per second or miles per hour or
Kilometers,
what?
or kilometers per hour.
Or kilometers per hour. Something like that is a unit of speed. So Anna, what did they say was the difference between speed and velocity? Oh, wait a second, you're muted. There we go.
Eli was messing with the mouse and he wouldn't let me click unmute.
It's okay, we've got mute and unmute going on. We got to get used to those controls. So Anna, what's the difference between speed and velocity?
Well, speed is just how fast you're going, and velocity is more like, I guess, like accelerating, like if you're going faster or slower or turning.
So kinda, so speed and velocity are basically the same thing, but velocity includes the direction you're going. So let's say I'm going 50 miles per hour in the car, right? So I'm going 50 miles per hour is my speed. But Austin, how would you turn that speed into velocity? What's the difference between speed and velocity?
You'd be going 50 miles per hour, like east, maybe?
East, yes, with a direction. And so, Anna, that's the difference between speed and velocity. Velocity has direction. So it's just a little more information, but otherwise it's the same thing. Like 50 miles per hour east, right, tells us the direction. So that's the difference between speed and velocity. So acceleration is your velocity over time, like your miles per hour. And so what that measures is the change of like how fast you're going. If you're going, you start off going kind of slow and then all of a sudden you speed up, right? That is accelerating. So let's go to this. This is an accelerometer. And before you start making it, which is what we're going to do, let's talk about it a little bit and talk about how to make it.
I was in my bedroom, sorry.
So first of all, I have a ruler here.
Will this ruler work?
Yes, it will. Also, something that's flat will work okay, but yes, that ruler. I have an index card attached to it, and I cut one of these out of this printout. If you don't have a printer at your house, you can draw that kind of shape. It's a half circle with some pie pieces in it. In this case, there are 3 pie wedges on each side, right? But it could have different ones. So you're going to cut out that circle or half circle. Tape it to this index card. Tape the index card. Here, I taped mine on the bottom too. And then you're also going to tie a washer on a string and tape that string so it's right in the middle here. So you can go on ahead and do that. You can ask me questions as you get going. Go on ahead and build one of these. Austin, build this. Yes, Austin?
I didn't say anything.
Okay, build this.
I'm drawing it.
You can draw it. If you don't have a printer, it's fine. You could draw the outside of a half circle by tracing around something that's round. You could also just kind of estimate it. It doesn't have to be perfect. It's really about these angle lines. It's really about when your string goes here and here and here. It's about seeing that angle line. Austin, build your accelerometer. Austin, cut this out.
You could move it over there.
Cut one of those out.
Move it over here. And then you can still be, you can see better maybe if you need help.
Darn it.
Nice, Charlie. Nice. Now tape that onto your index card so the tops line up. I found it handy to tape my index card down here also because it wasn't floppy then. Hey, Amara, you're welcome to sing in the background, but I'm going to mute you, okay? Or you can mute yourself, whatever. I'll mute you. You can sing. You can unmute yourself anytime you want. Nice, Austin. Tape it to an index card so the tops match. Austin, tape it to your index card so the tops match.
Will this index card work?
Yes. Nice. That's great. So tape it on that index card, Austin, so the tops match.
Yeah, remember when Mom and Dad got home they were two, I know. And then they had just the regular.
Nice, Austin. Now tape that on your ruler so it looks like this. It touches the end of your ruler. Tape it here and tape it here.
I'm not using it once. Are you crazy?
Tape the card onto the ruler at the top and then at the bottom.
You mean take the ruler and tape it to the card?
Well, yeah, that's fine, so that the ends match. Nice, Charlie.
I think a fountain.
Nice, Amara, and you've got tape on the bottom. That's good.
Right there.
Nice. Okay, so now tie your washer to a string. Austin, tie your washer to a string.
I don't know how to tie.
It's like tying your shoe. Do you know how to tie
I
your shoe?
can't tie my shoe either.
Okay, here, I'll show you how to do that.
Can I just tape it?
No. Tie it.
To where?
So look, you put your thing here, you cross two pieces.
Okay.
Let me see if I can get that in the camera good, and tuck one under. That's called a half hitch.
Like this?
Yes. Look, you tied it on. No, yeah, but you got to put a washer in the middle there.
What's a washer?
One of these. Or some little weight. It doesn't have, do you have a washer there?
Depends how big it is.
Mine is about as big as my finger, a little circle washer. You can use any size washer.
Okay, I'll get my washer.
Okay, tie your washer on your string. Anna and Eli, how are you doing?
Good.
Washer.
Finished.
When you said washer, I thought you were talking about a washing machine.
A washing machine. No, this here is a washer.
It's used to put on bolts.
Now I know what a washer
Yes,
is.
it's used to tighten a bolt. You use it with a bolt to keep the bolt head from going into the wood, or to use both ends to allow to tighten with each other. A bolt is like a screw, but it doesn't have a point on the end, and you use a nut on the other end. And so a washer goes before the nut. The nut is the piece that goes on the end of the bolt. We're using this as a little weight to give some weight to the string. Nice. Nice. And see, look, Amara doesn't have a washer. Amara has some little round doodad or some other kind
this
of
isn't
washer.
a washer?
Maybe it is a washer of it. It is a washer. Oh, it's a nut and a washer in one. That's what that is. Because the nut is the part
My
with the
dad
threads.
is so crazy.
It's okay. It's fine. You
Oh
have
my
something.
God.
So Austin, your tape roll is too
Why
heavy.
did he leak that?
Wait,
You sure?
Nice, Austin. You got it.
I peeled all the tape off of it.
Sorry, guys. I'm very, very.
the washer on the onto this.
So put the washer on the string and then tape the string right in the middle here. And my tape
Middle
is
of
on
where?
the back. My tape is not on the front so that this is free to move. But my tape is right here on the back, taping my string on in the middle so that it winds up in the front here.
Very sorry about that, guys.
No, it's
Doesn't
all
really know
good.
out here.
And you don't need very much string. It just needs to go across the card.
I'm very bossy and annoying mom.
Cool. Charlie, is yours made? That looks good. Nice. Wait a second. Charlie, you're muted. I'm going to unmute you.
Actually, just unmuted myself.
Okay. Oh, you unmuted you and so did I. Now we got you unmuted. Okay. What were you saying, Charlie?
I stupid me muted myself.
Oh, that's
Yeah.
okay. No worries. You've got your tool ready.
Chaos, sorry.
Yeah.
Chaos!
So for those of you that have your tool ready, move around the room with it and see. One thing is you've got to keep it like straight up and down, not hanging over like that, because using this to measure along here and here is what this tool is about. So what you will find is if you move and accelerate, that will swing. So let's say I'm walking. You can see if you are accelerating or decelerating. So you can walk around with it a little bit if it's ready. And then we'll come back together when everybody's ready and talk about what this is and how it works.
What do you mean I'm decelerating, you liar? I'm trying to make it go off the scale.
How's it going, Eli?
I made it go off the scale.
I believe it.
No, seriously.
It's super acceleration. Oh, Austin, wait a second. So look at this, Austin. Your card is upside down. Tape your card on this way. And your washer hangs like this.
Please don't kill us. Mine is.
I'm gonna try this outside.
Okay, that's a good place to try it. So you can use it. It has a lot to do with how you line it up and the orientation.
Let's see. I want to slip on the porch, so I'm gonna do it on the
I
cement.
made the washer go off the scale. Literally. Like it actually
Wait,
like
what?
Now what? Can't do that in this one. And you can't go like that.
Charlie, how'd it work?
What?
I was just asking Charlie how it works. So you can play with it a little bit and you can see acceleration, deceleration.
So acceleration is
Okay.
This way, deceleration is
I
this
don't
way.
know what was going on. It was like going like this.
Acceleration, deceleration.
All wiggly.
I get it. Try it a couple more times and let's see. And then we'll talk about how it works and what the results
I'm
are.
pretty fast, but
Put it out of the window of your car. That will work. If this doesn't work, put it out the window of your car.
So
it kept going this way like this.
nice, because you are accelerating.
It's because I'm extremely fast.
Exactly.
Some people might.
Dude, I'm never gonna stop.
I'm just
Sorry, it's so loud.
It's okay. Let's a couple more minutes and then we'll come back together, everybody, and talk about it.
You went off the scale again.
Let me see. Where's your washer, Austin?
Exactly. It went off the scale.
So look, you've got to tape it on the
Literally.
back here. Tape it really good right here on the back so that your string goes around to the middle of the front.
Ow! Found it.
Austin, tape it back on your accelerometer. And put a hardy piece of tape on the back of the ruler so that you're taping the string right in the middle of the front, but your tape is on the back.
Yeah, you're not getting off anytime soon.
Way to go. Nice.
Duct tape.
There you go. And all the way up to the top, Austin, look, put your piece of tape a little bit more up here. All the way up to the top, it'll help hold it.
Another piece all the way up to the top?
Just a little piece, but right at the top, so it goes all the way to the top. About one more minute, and then we're gonna come back together for a discussion moment.
Man, why was that piece of tape so heavy?
Okay, so let's everybody come back to the screen.
Yeah.
And so,
At a car window and it agrees with me that we're going 60 miles per hour.
so it's interesting, out a car window, that is a really interesting idea. So a couple things you might have learned. One thing to see is that if you're running along like this and it's facing forward, so, and Amara, come to a place to stop and engage and listen, and we can be part of the discussion. So when it is facing forward like this, you're not measuring it. If I am moving forward, this machine has to be sideways, right? Because this is forwards and this is backwards. So this has to be facing your direction that you're moving. Yes, Anna, like that. So you might hold it out to the side to look at it. Now, another thing, when you are the moving target and you're using this running, another thing that's happening is you're holding it. So you get this kind of movement and all this kind of movement, which really affects the string, right? It is fun to do because if you are accelerating, it's going to go one way. And if you are decelerating or negative accelerating, it's going to go the other way. So let's talk about using this in the car because that is very interesting. Number one, if you stick it out the window of the car, you're going to be in the wind, right? And so you're going to get more of a wind meter and not an acceleration meter. However, if you are inside the car and you do not have the windows open, you do not have the experience of the wind, you have a very good representation of acceleration and deceleration, because as you know, it's nearly impossible to go the same speed in the car all the time. If you're on a long trip and you're stuck on the highway for hours, you might use cruise control and pick the exact same speed. In that case, there's no acceleration unless you change directions, right? If you turn a corner, they actually call that a kind of acceleration.
Hopefully
But
this will get off.
That looks good, Austin. So, but if you took this in the car with you and you turned it sideways to the direction that you're going, it would do a very good job of showing you acceleration and deceleration. So that might be a really cool place to take this and play with it, right? Running is too, because you can see when you
were real close to knocking on the door.
When you're stopped and then you start running, you're accelerating a lot. Or if you're running and then you come to a walk or a slow down, you're doing negative acceleration a lot, right? And you can measure that with this tool. But in a car is a really cool place to do that with this, because your acceleration is changing all the time and you can measure it with this. Does that make sense?
Yep.
Awesome. Who has a question? Amara.
I have a question about sharing time.
Okay, what's your question?
When it's sharing time, could you share your screen to everybody what I sent you on email?
Yeah, I probably could.
Because I want to show everybody my art.
Okay.
It's the thing I showed you today when we were tutoring.
Right. So I am going to switch to another video. Hold on just a second here, and we're gonna go to this one. I'm gonna do it here. Okay, here comes a screen share and another video.
Woo! Hopefully this one works.
Hopefully this one will work, Charlie.
Awesome.
Hey, it's Professor Dave. Let's discuss position velocity.
He knows a lot about the science stuff, Professor.
What the heck is that?
Often be asking questions like, where is an object? And how fast? The answers to these questions, people frequently utilize the concepts of position, velocity, and acceleration. So before we go any further, let's define these terms. Position is simple. It's just where an object is in space. Usually this is discussed with some kind of reference point or axes in mind. And we might express the position of an object as being some distance from this reference point in meters. Velocity is the change in position over time. So if this object travels 5 meters in 5 seconds, it is traveling at a velocity of 1 meter per second. And acceleration is the change in velocity over time. So if this object starts at a standstill and over 5 seconds gradually speeds up to 5 meters per second, then it is accelerating at 1 meter per second, or 1 meter per second squared. So that's how we define position, velocity, and acceleration. Now let's discuss each of these in more depth. When we talk about position, we could discuss distance or we could discuss displacement. The difference here is that distance is a scalar, while displacement is a vector. Let's say you and your friend get dropped off by the school bus at this intersection, and your house is here. Your friend begins to walk down the street and up the driveway like a normal person, but you find yourself so overcome with excitement to play video games that you decide to plow through the yard in a straight line to the door. Your friend has to walk 20 meters down the street and 7 meters up the driveway for a total of 27 meters. So, using the Pythagorean theorem, we find that you only had to walk about 21.2 meters, and you probably got there a little sooner. What we can say is that you walked different distances, which are represented by these scalar values, but you both had the same displacement because you ended up in the same spot at the front door. This vector, which follows the straight line path, is the displacement vector for both of you. And we can report your position with x and y coordinates like this, 20, 7. Or we could report the magnitude of the displacement vector, which will be equal to the shorter distance you traveled, and calculate the angle off the horizontal using trig functions if we desire, in order to report the direction of the vector. Next, let's look at velocity, which is the rate of change in position. Most people assume that the words speed and velocity are synonyms, and in everyday language they are. But the difference in physics is that speed is a scalar and velocity is a vector. If a group of kids are playing hide and seek and they all run away from the seeker in different directions, it is possible that they all run at the same speed, because speed only has magnitude and no direction. So they could all run at a speed of 3 meters per second if they are quick little devils. But each kid would have a unique velocity vector that has a magnitude of 3, but also describes the direction of motion, most likely using the seeker standing still as the point of origin. Velocity vectors will be extremely important as we move forward with kinematics, where we will study the motion of objects. In general, average speed can be calculated by taking the distance traveled by an object and dividing by the time it took to do so. So if you walk 85 meters in 46 seconds, you are walking at an average speed of 1.85 meters per second. To find average velocity, you can do the same, but you would have to divide displacement by time. Lastly, we have acceleration, which is the rate of change in velocity. This is always a vector because acceleration must occur in a particular direction. If you are in a car that is standing still and you press on the gas, the car will begin to move forward with a fixed acceleration. It might accelerate slowly, so the vector may be on the shorter side, but this constant acceleration will cause the velocity to increase at a fixed rate. Let's say an additional meter per second every second. So over 5 seconds, it will reach a velocity of 5 meters per second. Let's say you see a skunk in the middle of the road. It's your most favorite animal, so you slam on the brakes. We can describe this as a deceleration, which is an acceleration in the negative direction. Since you are going from a moderate speed to a standstill in a very short amount of time, this vector will be quite long and pointing back towards the origin. Now we understand distance and displacement, speed and velocity, and acceleration, and we can categorize these as being either scalars or vectors. Before we finish, let's look at a moving object like this marble rolling to a stop and visualize all 3 of these vectors as the object moves. First, with displacement, this vector will just elongate as the marble rolls and will span the distance traveled. For velocity, the vector will point forward as the velocity is positive, since it is moving in the forward direction. And the vector will move along with the marble, but it will decrease in magnitude as the marble slows down, until eventually disappearing when the marble comes to a rest, where it has 0 velocity. And then for acceleration, the vector points in the negative direction, since velocity is decreasing or becoming smaller per unit time. But it will be constant in magnitude, since this is a constant deceleration due to friction from the surface it's rolling on. We can view all 3 of these at once, just to drive things home. Make sure you understand the magnitude and direction of each of these vectors at each moment in time. Let's check comprehension.
Okay, we are going to do our comprehension together.
That did not work either.
Sorry, you know what?
Finally, the video is over.
You know what, Charlie? I think it has to do with internet connection, and I'm not sure that the things I'm sharing, there's enough power to get them to you. So let's talk about what we just talked about. One of the big differences is a vector. They talk about that, and a vector is an arrow with a direction, right? And so what's the difference? When they talk about scalar, that's again a big word, but it means it can be placed on a scale, right? It can be measured. So something that's scalar, like speed, can just be measured. It can be placed on a scale, right? But speed doesn't have direction, right? A vector has direction. Okay, so the last thing I want to do together before sharing time is to work together on this worksheet. These are the math computations that come along with working about acceleration. If you have this printed, find it. If you don't, I'm going to put it on the screen, right? And you can work on a piece of paper. But I'm going to go on ahead and share my screen to this. So we have...
This stuff is really confusing, so I don't really know if I want to participate in this right now.
You know
what?
what?
It's Turbo the snail.
This part might be confusing for all of you. Don't worry about it. We're going to do it together.
Look, it's Turbo the snail.
Okay.
Anybody watch the movie Turbo?
I have when I was little, but I'm not obsessed with it like I used to be.
Okay, so
Me
let's
too.
look at what they've got on the top of this worksheet, acceleration. And look in between the car and the snail, right? They have a box there.
I mean,
And
they
this
all
looks somewhat complicated, but it's not so much if we
Very
understand it.
complicated.
And so let's just see, right? Take a moment with an open mind to just understand this. So it's an equation, and it has acceleration equals, right? So we can figure out the acceleration using this method. So V in this case is velocity, which is the speed and the direction. And it says V sub final. And all that means is how fast were you going in the end, right? Your velocity in the end. So if we look at problem 1, so, you know, those of you that think this is challenging, turn around and face the screen and get engaged and pay attention.
Sorry about that.
And it'll help you.
I got distracted.
Okay, it's okay. And if you turn, I believe it. I just want to have you listen to this part and we'll go through it together. So we're in the box at the top and it says acceleration equals V sub final. So that's your final velocity minus your initial velocity, V sub initial. So in problem 1, the final velocity is 60 and the initial velocity is 0. That means something started at 0 and went to 60 meters per second. That's probably a car more than a snail, right? And then they did that in 10 seconds divided by time. So let's look at this. In the first case, it's going to be 60 minus 0. So
It's
that's
60.
60, right? Divided by 10. So 60 divided by 10 is 6.
Yeah, I knew that already.
So I am going to
Are you sure?
switch to a whiteboard and see if I can draw this for you on a whiteboard. So we have 60 minus 0 divided by, whoopsie, I'm drawing so badly, 10 equals, so 60 minus 0 is 60. And it's divided by 10.
And that gets you 6.
And that
Can I write
equals
it down?
6. The other thing I'm not writing here in all of that is all the units, right? But
Right.
let me see here. So the acceleration then is 6, right? And acceleration is measured in meters per second squared. So that first one here is 6m divided by s squared, meters per second squared. So, and the units, I'm not so worried about you following along with those now. We'll catch those, right?
Okay.
So let's look at the second one.
Miss Lisa,
Yes,
I can't see any of what you're doing either.
you can't see the screen share at all. Do you have that acceleration piece of paper in front of you, Charlie?
Honey, you can use that.
I've got it screenshotted.
That's fine. Screenshot it is okay. Charlie, do you have the acceleration paper in front of you?
No.
One question.
Charlie, I'm going to email it to you.
I got one question.
Yes.
Where do I
You
write
already
the 6?
In the answer blank where it says acceleration.
Okay.
That's the answer for number 1 is 6. Charlie,
Okay.
I'm going to head to my email and email you that paper we're working on.
We're good. I've got it pulled up.
Oh, you do? Good. Okay, good, good, good. So, Charlie, you see that chart we're working on, right, with the car and the snail?
No, I can't see it.
Okay, I'll pull it back up on the screen share.
Remaining.
Just a second. I'll get it back for the others of you. Here we go. This one, share that one. Okay, so let's look at number 2. What is
Okay.
B sub final in number 2?
Oh, I'm hungry. Mom, I'm hungry. I'm hungry.
So you know what? Those of you that are hungry and those of you that are steering with a pizza.
I'm always hungry.
I know. Let that go for a minute. You're in class for a few minutes. We have about 10 more minutes of content here, and we're going to go to sharing time. So, and Charlie, what did you want to say, Charles?
The screen share is working. That's weird.
What's working?
The screen share is now working. I don't know
Good.
why it wasn't working before.
You know, I think with laggy internet, it's a little tricky. So let's look at problem 2 then. Charlie, will you do problem 2 with me? Okay, so we have the final velocity minus the initial velocity. What is that?
45.
Exactly. Charlie was doing this one, Amara. So
Oh, sorry.
it's okay. Charlie, do you see that? 55 take away 10?
Yeah.
Right? And then that's divided by the time.
But I don't see those numbers written anywhere.
No, it's because I can't write on top. Well, maybe I can write on top of this. I don't know. Let me see if I can.
I think you can. I mean, you see where that pen is up on the top of it? I mean, maybe you should hit that. That. That pen right there. Up there. Up there, right next to the A. The blue A and the red A. Miss Lisa, do you see it?
No, this.
Yeah, that. Hit that.
That's text highlight
Where's the
color,
red
though.
one?
That highlights the text. I don't think I can do it with a pen.
Say hi to Greta.
That though.
Anybody want to say hi to Greta? She's in here.
Anyone right now
There's
because
Judah.
I'm actually on my
Miss
phone.
Lisa,
Yes, sweetie.
we know how to draw on it. So go up to the top and there should be this black button. Hang on. Look at that black button. So at the top of the screen that we're sharing, if you go up to like the top, it'll say you are viewing Lisa screen, and then it'll say next to
Make
has
sure
like
to Skype this time.
a option. And you click on that, it sits down in the station radio, and it'll say something. And then you go to like Anna, I don't know how to pronounce it. Click that, and then you can draw on it.
Annotate.
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 I don't know if you have it up.
Let me stop sharing that for a second. Where do you see annotate, Anna?
Okay, so if you share a screen,
Yeah.
if someone shares a screen, and like I want to draw on it, I go to the top and it'll say you are viewing whoever's sharing the screen.
Yes.
And then next to it, it'll say option. And go down, it'll have a bunch of lists, and then on one of them, it's annotate, I think.
Annotate.
And you click on that, and then it will allow you to draw.
So at the top, you go to share screen.
Right. And I'm in share screen. Oh, if there's advanced.
I don't know if this counts
Oh, it's basic.
as sharing, but say hi to Greta. And Greta will say hi to you.
Hi, Greta. Hi, Gretty.
It's the dog. It's actually the dog.
You're a cute doggy. You're very cute, Greta.
So go up to the top
says
middle of the
things.
screen.
Oh, Anna, I got it. I think on the top 3 dots. Show names, disable participants, annotation.
Hit annotation.
Yeah, but I don't see. I see show names of annotators.
Here. That's annotate.
Pause, share, remote. Oh, annotate. I annotate. You guys are the greatest.
Yep, I think that's it.
It's
Try.
it. Awesome. Thank you.
Great.
Oh, I see what I'm doing wrong. I'm doing it normal division, not long division. Miss Lisa, how would you
Yes.
write out the division problem? 45 minus
Okay.
15.
Here we go.
Like, how would you write it out? Which one's on the outside? 45 or 15?
So your 15's on the outside.
Okay, that's one of the things I was getting wrong.
Okay, now we've got, boy, I don't write very well. I have to get better at this. Okay, so and then we've got the second one, right? We did 55 minus 10.
Yep.
Divided by 15.
I forgot how to do long division.
Okay, Charlie, can you keep working on this second one and get up the answer? What is the answer to number 2?
I'm not good with, I haven't gotten to doing division in my math stuff yet.
Okay, so here, so look, that's 55 minus 10.
That's
We're going to divide it
45.
by 15. Right? And so this one here, 60 minus 0 is 60, divided by 10 is 6. 55 minus 10 is 45.
That's the thing.
What?
I forgot how to do long division. That's the thing.
So what if we did 45 divided by 15? How many 15s in 45? 15? 30?
Oh, 15,
45.
30, 43.
Yes.
And then 5 times 3.
So let's do the next one. Anna, you help me with this one.
15.
10.
Just switch it around.
Wait, this is very confusing. Because I just did 5 times 3, and that's like 45.
What?
5 times 3 is 15.
So
Oh.
Okay, so let's let Anna work through this one this time.
I did 40 minus 0, which is 0. And then 40 divided by 4 is 10.
Right, 40 minus 0 is not 0, it's 40, right?
40.
Yeah. Divided by 4.
Made me do the whole thing wrong. My God.
It's okay, Amara, follow along and watch. It's no big deal. We'll get through
I
these.
am not watching right now. I have a screenshot right here, and
Okay.
I can't watch.
Okay. So, Eli, how about the next one?
Okay.
So, what's the final velocity?
Final velocity.
On number 4.
Can
Can you read that, Kit? Are you a reader, Eli? Can you read that chart?
Yeah, he can.
Awesome.
Okay, so number 4.
And I'm done for the day.
So final velocity on number 4.
Okay, let's see. This is gonna be pretty hard, but I don't know. Let's see.
It would be here, right? That's final velocity. What number is that?
40?
Yeah, say it loud.
40?
Awesome, you got it. For the final velocity is 40. Then the formula says we subtract the initial velocity. What's the initial velocity for number 4, Eli?
60.
Very good. So we've got 40 minus 60. That's kind of interesting because 60 is bigger than 40. So if we have 40 and we take away 60, it's going to be a negative number, isn't it? And then we divide by the time. What's the time on number 4, Eli?
The time on number 4?
Yes.
10 seconds.
Beautiful. So now this one is interesting. Charlie, will you please take that off of there? Thank you. So now we have 40 minus 60. That's actually negative 20. If we had
negative 20.
Yeah, negative 20, that's a 2. And then you divide that by 10.
Can I help you with this one since you're not on division?
We have negative 2. That means that this is slowing down. So those of you drawing on the screen, I'm going to disable your drawing function soon. That's a waste of time in class. Please stop doing that and delete them off the screen. I'll delete your functions there, right? I get if this is challenging. If it's challenging, engage and try. It's okay. You don't have to be able to do it. Follow along, okay?
I know it.
Good. You're doing great, Anna. And so let's go and do the next one.
What do you know? I don't have drawing function.
Cool. So will you delete your drawing because soon I'm going to delete your ability to draw on the screen.
No, I don't.
Oh, you don't know how to do that. Okay.
I don't have drawing ability because I'm on a Chromebook.
Why?
Nothing. So I can't draw.
Okay.
I can. I'm on a Chromebook.
Either that or I just don't have the ability to draw. Because one, I can't delete that blue square. So I'm guessing it was somebody else.
Okay. So, why are we even bothering to work with numbers? What is the point here? What's going on in these equations?
Velocity?
Nothing's a fair answer, Eli, especially if that's what you understand. But there is something going on. So let's talk about what it is.
Velocity.
We're using velocity, right? Velocity is the speed with the direction. We're using the change in velocity over time to compute what?
Vector.
What is the whole idea we're computing? The change in velocity over time.
Change in velocity over time.
Change in velocity over time. That means, let's think about that. In a car, that means going slower or faster during the half hour we're driving.
Not going the same amount of speed constantly.
Right. What is that change in velocity over time called?
Decreasing and increasing.
Decreasing and increasing what?
Increasing acceleration.
Acceleration. Acceleration. Acceleration is the change in velocity over time, right? And that's what that equation was. We're going one speed, we're going another speed. What's the change in that? over the time period that you're doing it. It's acceleration. What is this for? Who can tell me? Raise your hand if you can tell me what this is.
It's
Hey,
a.
I said raise your hand, Amara.
Oh, sorry.
That's okay.
It's a it's it's like a speed meter.
Kind of. It's not speed because it doesn't tell it's speed. It tells something else. Austin.
It is a meter to measure velocity and speed.
Kind of. It doesn't measure velocity or speed because this doesn't say how fast we're going or how slow we're going. Velocity is speed with direction, right? And velocity is speed with direction. Speed is just how fast you're going. What does this measure, Eli? Anna?
Doesn't it measure like whether you're moving like faster or slower?
Yes, whether you're going faster than you were or slower than you were. What's that idea called, Austin?
Accelerating and deaccelerating.
Yes, acceleration and deceleration, or deceleration in science, they more know it as negative acceleration. Eli, and that problem you were doing, which you were doing a really good job with, and we ended up with a negative number. That's a negative number. That's slowing down. That's deceleration.
Can I just do like a can I say this math problem?
Sure. And so
it kind of has to do with increasing speed.
Cool. Let's do that.
Say you drop an apple and a bowling ball off of a tower. Which one do you think would land first?
I know the answer, but let's see about other people, because that's a really cool thing. What if you were on a tall tower and you dropped an apple and the bowling ball? Eli thinks the bowling ball would land first. Amara, what do you think?
I think the bowling ball because it's heavier.
It's a really good idea. Anna, what do you think?
Well, they're both going to fall at the exact same speed.
Well, if you pick bowling ball, you are incorrect.
Why, Austin?
Because one great scientist, who I forgot the name of, made a theory that both objects would fall at the same time. And they did.
And
the apple and the bowling ball would hit the ground at the same time.
They do. It's kind of a fun experiment to try yourself at home, because you can get something light and something heavy and drop them off your porch, for example.
Watch. I'll prove it.
Sometimes right there in your room, it's a little tricky.
So I'm gonna drop a roll of tape and a car. See, they're both at the same time.
And so listen, this is something fun you can try at home. And it's tricky when you're just going from here to the floor. But if you're going off your balcony or from a tree or something, and the other thing is if you pick a feather, it's going to go like that. And the wind resistance is going to keep it from going down, and it'll make them different. But if you pick things that are similar, a very small rock and a very large rock, boom, they will hit at the same time. And that's because the force of gravity is applied to them equally. Our next we have one more week in this unit, which is going to be force. And then in May, I'm going to do all about gravity. And we're going to talk about science experiments like that, about understanding gravity. Hey, Eli.
Isaac Newton made that theory? No.
So wait a second. Yes, Austin, it was Newton that made that theory. And now let's go to Eli.
Can I play this?
Sure. Very cool, Eli. Very cool.
Thank you. It's called Kiss Kiss.
Okay, so we have a little bit more sharing time here. We can be done with the acceleration lesson. And
Show
so,
everybody.
yes, and so and Amara emailed me something. I'm going to see if I can find that. I don't know if I can share this or not, Amara. Let me see.
I could share it.
I think I've got it.
Okay.
Oh, I do. Oh, it's fun too, because it's a movie of you drawing.
Yep.
I didn't make mine because turns out my thing doesn't save, so I lost all my progress.
Oh, I'm sorry. Of your movie?
Yes.
Oh, I'm sorry about that. Okay. Here is a screen share. Amara, is there sound on this?
Nope.
Okay.
Okay, just press play.
Who's that?
This is
That's
Amara drawing.
It's my OC.
You want to see that one more time?
I'm good.
So that was kind of cool. That's Amara turning her pencil drawing into,
And I
you
can
can
show
see
you
she's
that.
got into the screen by defining the lines and then filling in the colors. You can see that's how people go from drawn art to digital art.
So I just erased everything and then just colored it in. And then did the shading afterwards.
Exactly. Cool. So I am going to,
And here's the original drawing.
and there's Amara's original drawing that she turned that into digital art. Did you draw that drawing or did you trace it?
I drew it.
Very cool.
I never trace anymore. I don't trace at all.
You don't trace, you drew that freehand and then turned it into digital art. Cool.
Mhm.
Cool,
Did she
cool.
have to look up like a YouTube video to
No.
learn how to do art?
No.
Probably
I
not,
didn't.
but the thing is everything's
That's
about what
actually
you
my
practice,
OC. That's
right?
my
So
original
Amara
drawing.
practices that.
Can I share something?
Yes,
Hold on, it's gonna take a few minutes.
that's okay. We have a few minutes. We have 15 more minutes of class time.
Alright, so what are we doing?
The book of video games.
Hold on.
Very large yet full of video games.
Very cool.
Aw, this is the one I got from the Easter Bunny. It's completely blank. Where is the book of video games?
Anyone want to join in?
Huh?
Is that where you're sharing collaborative screen art?
Apparently.
Because it's looking like a dark and stormy night.
I would draw if I could.
But we can't.
What's he do?
Yeah, we don't have the power.
That's okay. So while that's going on, Austin, what is it you have there to share?
This is the book of video games. This is the second copy.
A book of video games? So that's interesting. Does it tell you what video games there? Oh, it's your drawing book of your own video games.
Uh-huh.
Do you have any of those you want to share?
I was trying to.
I have actually like a complete one somewhere. This is the second one.
The second one. Do you want to share anything that's inside of there?
I made cupcake cart.
Cupcake cart? Like Mario Kart, only with cupcakes?
Yeah, I made my own version.
Nice.
Actually, I even made my own character. The
Oh,
burritos
can you show us
obvious
that?
to me because I love burritos.
And your
From
character's a burrito?
Yeah, there's also a few other ones.
Oh, cool. Is that your character's
You only
face?
see like their face.
Yeah, yeah.
Unlike the character select, so I did that.
Cool. That's a cool way of writing.
I also made racetracks, carts, actually a lot of carts.
So Anna and Eli, what's next on the car agenda for you to each figure out?
I think we just need to figure out some, like how to, I think he has to work on how his gear is going to turn the wheels. And no, it tries to turn the wheels. Well, he has some glitches with like turning the wheels. I want to see if I can make mine go faster, and maybe, I think I'm going to try and exchange, these are still the heavy toy wheels I was using. I think I'm going to try and exchange them for the vitamin lids.
Vitamin lids. That's what she's got, lighter weight wheels that'll make it go better because it's not carrying so much weight.
I need to re-glue my motor. And I want to keep working on just like the position of the solar panels too, and see if they want valuable information. Hang on one second. And the position of the solar panels.
The position of the solar panels to gather the sun. Does that kit have a remote control, Anna?
No, it's just if you want it to stop working, you have to shade it or disconnect the wire.
That makes sense.
Or the motor from the wheel. This can slide through, so when I move the motor there,
right,
it can slide away. So, oh, that's another glitch. I have to figure out how to keep this here in this position while spinning, so it keeps sliding out, and then the motor can't reach it, and it stops.
Cool. I want to come back to that in just a second. Austin's waiting with his hand raised, so let's check on Austin, and then I want to come back to the car. Austin.
So I wanted to show you something, but I don't know if you're gonna let me do it because it's toy soldiers.
Yeah, as long as nobody gets hurt.
Yeah.
Okay. I totally get it.
Okay, let's do Austin's thing. We'll go to Amara's thing, and then Anna and Eli, I want to come back to your...
Down there. You see it?
You two. Yes?
I made like a toy soldier base.
Oh, cool. Very cool.
Actually, I made it yesterday.
Nice.
It's got tanks, helicopters, and jets.
Cool. I think that stuff's fun to share, what's going on, and I think especially for your ages, it's cool to share and connect like this. Amara, what did you want to say?
I'm also very good at piano as well.
You want to play us something on the piano?
Yeah, I don't know the whole thing, but I do know some of it.
Cool.
So good. Look out light with the wall. Oh, the dog! The dog! The dog!
Just a sad song. I'm just a sad song.
Sorry, I was playing
I
out
really know.
Nice. So really nice. And Austin, I just muted you when it got a little wild. Try to chill out for a little while, Austin. We got just a few more minutes in class. So,
I was just trying to play with my dog because if I don't pay attention to her, I have to send her back.
I get it. I get it. So beautiful music, Mara. Fun for sharing that. Anna.
Well, I guess this is really exciting to me. It's not about the car. So as for with my dad's job, he does train dogs, but he also we have our own dogs, and some of it his dogs he competes in like the Shipton sport, and his youngest dog I've been working, and he says I might be able to take her to the trial and be her handler.
Wow, very cool. So that's like one of those shows where you show how good your dog can do stuff?
Yeah, there are a lot of sessions in it. Like you have to make your dog down. You have to tie your dog down and have him, and you walk away and like you're not holding, well you might be holding your leash, and then he has to stay there and stay down while all the like another dog goes through all the obedience skills, the sit and or all the other some of the other stuff in front of him, and they have to just go the long down. And
My dog would be terrible at that.
That's good. Hey,
yeah,
Eli, what did
I
you
have a
want to
hard
add?
time just to get her to sit.
I'm not positive, but I think my dad's gonna let me eat. Well, she doesn't. I don't think she's gonna go to that. But if she does, I might get to be her handler. Just saying. I think that my dad's second oldest dog might be sort of like mine-ish this year.
Very cool. So Anna and Eli, what's the best way to get a dog to do something that they don't want to do that you want them to do? What are
I
the
just
best
let my
tricks?
dog be free.
Well, with ours, we have, and you have to correct them. Like when your parents say no, like you have to correct them. And you can teach your dog to understand the word no, but you also, in training our dogs, we have these prong collars. Now, these collars are just like a little, they're almost like little spikes, but they're not really pointy, they're flat. And you put them on the dog, and when you pull on the leash, it gives them a little pinch, and they're like, oh, I wasn't supposed to do that. And then you can I use treats and balls.
Good. Good.
I
good,
don't think
good.
my dogs would like that at all. My dad would not agree to that.
There's different ways of doing things, and I think it's just interesting. Anna's family does a lot with dogs.
My dog's too stubborn.
My dad.
I mean, it would be easy to get her to stay if you put like a patch of grass right there. It would be like the easiest thing to get her to stay, because she would be like, "No, I don't want to go. I want to keep smelling this. No,
Yeah, so
no,
you have to work
no."
with them. And we work on just standing and staying, and how you do that, you like hold a treat in front of her nose and you say, stay, and then you let her eat the treat, and then maybe you go back and get another one. And then you wait for a second, and then you bring it right into her nose, and then you give her a treat.
Actually, my dog doesn't know no. So guess what I did instead? Taught her instead.
What?
That's how my grandma says no. So I taught her. So every time she's like, I'm going upstairs and tearing up a toy, I'm like, Greta.
So
Yeah.
one more thing I want to go back to, because I think it was cool and an interesting thing, and it's physics related, is Anna's and Eli's cars. You're dealing with electricity in there, right? And the electricity from the wires has to touch somehow. Sometimes you wrap them around each other and put tape or something to keep the wires touching. That's where the electricity goes through. So Anna and Eli, also it's conceivable and interesting about making a switch for your car. What does a switch do? Does anyone know what a switch does? Anna?
It can like tell something to turn on or turn off. Like you use the switch to turn on the lights or turn on the fan.
Exactly. And a switch is an interruption.
Start operating. It like
Exactly.
opens a circuit.
Exactly. A switch is an interruption. It connects the circuit or it opens the circuit. So it's possible, Anna, for you to build some sort of little switch into your car too, as you adapt to it. Something that allows it to connect or not to connect. And so that could be interesting.
That would be fun to experiment with.
It would be fun to experiment with. Eli, what did you want to add?
I just want to add Austin, I just wanted to say, if you want to, you can drop your dog off and see if you can train him.
No way. She's too stubborn. You don't understand how stubborn my dog is.
Nice offer, Eli. You know that sometimes when
We
we
have
have,
a lot of grass for him to sniff.
there you go. Sometimes when we have challenges, we
And
can
there's
consult
pictures
people who are
to take,
professionals.
Sniffy.
And she'll literally lay on your face when you're in the bed.
And you
Plus, she's a big dog. Big.
Not so fast, Austin. Then you teach her no. Every time she tries to do that, you give her a tug, or you tell her to do something that she did something wrong with, like a little pull on the prong collar. Now,
Also, she's insanely strong for no reason. It's so weird.
Now, Austin, I just want to say, we have a way of getting dogs sort of not
A clicker?
to get used to strangers and lick and love them and not lie on their face and then lie in your face. And do
I like
that.
her lying in my face. It's comfortable.
We sometimes we have this big a small like building attached to our house that's called a kennel. And the kennel, quiet, Anna!
She's just trying to help, Eli.
No, she isn't.
Or maybe she's trying to annoy you because she's your big sister.
Oh, yeah.
Honestly, I think she's just trying to help. Let's let Eli finish up. Let's let Eli finish up.
He's done.
Okay. So, good job, everybody in class today. Take this accelerometer with you in your car. Turn it sideways. Use it in your car. See how it works, okay?
Okay.
Super.
Okay.
Next week, we're doing force. It's another physics concept. I will send you the information. We'll do another experiment next week, okay?
You know what? I think I just figured out the dog that you guys definitely couldn't train. His name is Arlo. He's dead, but if he was still alive and you tried to train him, he would do what he does to strangers.
He would be
You
untrained.
want to hear what? You want to hear what that is?
What?
Bite their face off.
Oh my god!
I used to live with a dog that did that.
We have a dog that
That
likes.
is so aggressive, dude. I would not.
Yeah,
want to-
he was a little overprotective, but he lived a long and happy life.
Anna, how do you teach a dog that bites not to bite?
I don't know. I don't know exactly. I think, but we do have. We're boarding one.
It's actually good that dogs know how to fight, because if a robber or someone else comes and breaks into your house and your dog knows, your dog can just bark at him. Because my dog, Cole, we taught him, we made fists like this, and he's bit them. We're teaching him how to do that, so then when someone breaks into our house, he can protect us.
A lot of different ways to train dogs.
Yep.
That's not really a good idea because.
No, it actually is. My dad is very
you
smart.
want to know that there's a burglar in your house. So if a burglar breaks into your house, the dog will go.
Yeah, but if the burglar does this, Cole will bite his hands.
Interesting. So you know what? We've come to the end of class time for today. We're going to wrap it up here. And I will see you a week from today at 10 o'clock.
Bye.
Okay. Oh, yeah, and I'm getting my new desk this week.
Yay. And a couple of you I'll see before that too.
Oh, we might get chickens
Now I
this
have to
week.
deal with this dumb
You might
chair,
get
but-
chickens. You might get a desk. Yay. Have a great week.
I'm excited.
Welcome.
I'll see you next week. Maybe before.
Bye.
Bye.